The last objective for this unit is that you model trigonometric behavior. That means that you use what we just learned and apply it to the real world. Obviously, this is really important. It's kind of the reason we do all this. So, we're going to start, this example is just a specific example that gives you a table. Not all of them will. Sometimes you'll get pictures, sometimes tables, sometimes just descriptions, and every one of these is kind of different, but here's one example. So this table tells you the altitude of the International Space Station as it orbits the Earth. And the reason that this is sinusoidal is that orbits always are. They look more like this. This is an exaggeration. But they're closer, and then they're farther, and then they're closer, and then they're farther, and they're closer, and they're farther. So that creates something that looks like this. Closer, farther, closer, farther. Again, my drawings are pretty terrible, but that's the idea. So, first question is, what is the maximum value? Well, there's not a lot going on here, so we'll find the maximum value just by looking for it. I see a 419 right here. I don't see anything else that's bigger than that. So my 419 seems to be my maximum value, so I will write that. That is 419 kilometers. That's how high the International Space Station gets, I guess. The minimum value would be the lowest value. Okay, well, I can do that too. So our minimum value, I see a 411 right there. Looks like I see a 411 again. So my minimum value is 411 kilometers. Sometimes you might have to estimate, but this seems to be very exact. The midline might be here, but just so you don't think it always has to be, the midline is the middle of the max and the min. And since I already know those, I can just find the middle of them by adding them together. 419 plus 411. And dividing by 2. That's a 4, by the way. That's finding the average of these two things. Now, when you do this, you get 415 kilometers. 415. And that makes sense. 415 is indeed the middle of these two things. And it's on the table, too. So, in case you weren't sure about it, 415 does appear to be the middle. The amplitude is the distance from the max to the midline. So, you can either do max minus midline, or the distance from the midline to the minimum. Either one of those, 419 minus 415 is 4, or 415 minus 411 is also 4. So the amplitude is 4 kilometers. If you accidentally did this backwards and get negative 4, you know amplitude is the absolute value of that anyway, so you would just make it positive. The period of the function is probably the hardest thing to find here. So the period is how long it takes to go through one cycle. So we'll do my best at this. Assuming that it starts at 0, that's at 415. Let's see how far it goes. Well, right there it's at 415 again, so maybe the cycle is 46 minutes. But if you look what happens, it starts at the midline and it goes down to the minimum and then back up to the midline. That's not a full cycle. That's only from the midline to the minimum and back. A full cycle also goes to the maximum. So if we keep going here, you'll notice it hits the maximum and then it goes back to the midline. Now that occurs at 92 minutes. So it looks like 46 was only half of a cycle. And if you want to plot this out, you'll see it. If you graph this, it starts at 0 and then it goes down and then back to the middle and then back up and then back down. Now that's a full cycle. So the period of this function is the time it takes to complete one cycle. That is 92, and in this case it's 92 minutes. F is the last question before we're actually able to write it. Does this function appear to be positive sign, negative sign, positive cosine, or negative cosine, and how do you know? Well, I already kind of drew it. I would figure this out by actually imagining it or drawing it. This starts in the middle, and then it goes down first. So this is a negative sine function, and I'm going to write it, it starts at the midline, then goes down. So you might need to reference your notes for each of these 4 where they start and which direction they go. But it'll always be one of those 4. Finally, we get to the interesting part, which is to actually write the function. So a of t is going to represent altitude and t represents time. So we start with this. Let's see. We I have a negative sine function, so I'm going to write negative and then sine, and I'll fill this in. Right here is the a. Now a is the absolute value of amplitude. My amplitude was 4, so I'll put a 4 right there. The negative I already knew because of the sign. And then I'm going to have a t in here. Now, just so we remember, 360 divided by b gives us the period, but it's also the opposite. So I'll actually just undo that, just so we know. 360 divided by the period gives us b as well. So these two things are both true. So I'm going to do 360 divided by 92, and that gives me 3.913. Or maybe I'll just say 3.91. So that tells me that b equals 3.91, and that's what I'll put right here. So 3.91 and then t instead of x because they told me that. And then plus k, and k is always the midline, which we calculated was 450. So that's my formula. I've got my a, my b, and my k in there. Finally, it asks me for a of 180. So I'll write a of 180. Now you guys remember from unit 3 that this just means we plug in 180. So this is negative 4 sine of 3.91. Whoops. 3.91 times 180 plus 415. And I'm going to type this all in at once. Negative 4 sine 3.91 times 180 close parenthesis plus 415. I'm literally typing over here. And I get 416.12. And since this is a measurement of A, that's kilometers. So it says interpret what your answer represents. Well, 180 is a time, so that is in minutes. But I think I'm going to write 3 hours instead of 180 minutes. So after 3 hours, the space station, maybe I'll just write the station, is 416.12 kilometers high. So that's how high it is above the Earth. Underneath it says part I, that's just a typo, so there's nothing there. So it seems like there's a lot going on here. There is. Good luck doing the next problems, but remember, these are fun. This is the point of learning all of this. So our objective today was that you model trigonometric behavior, and that's what we did right